Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today as it is every day here in my virtual classroom. If you step on inside, hey, you know what, we actually got a nail biter in this game. I don't know, the score, I think it was a 1.2627, something like that. Let's see. Yeah, so I did a prediction in my last video that the Washington football team would win like 24-10 or something like that. That's not going to happen. Nail biter probably down to like a game-winning field goal or something like that, or just running out the clock, I don't know. But okay guys, let's go ahead and get going with this one. This video is going to be on multiplying polynomials with other polynomials. Now my last video was a monomial with other polynomials, and now this time we're going to do ones that are not a single term with a single term or multiple terms. Now it's multiple terms with multiple terms. My personal favorite being binomials with binomials, where we get to use something called the FOIL method. Now in order to make this video as quick and painless as possible, down below in the description, I'm going to leave a link to some other things where I teach this a little bit more. So this one will be a little less teaching and a little more doing. I'm surely going to introduce some of it to begin with, but you'll see a little more steadfast pace and kind of the way of like, this is where you can be with it. And I'm not going to try and do too many diversifying tactics here. So a lot of problems to go over. I think a couple word problems here in the end as well, just to get some context. But let's go ahead and get started. Now this sheet for this homework thing for my students would say multiply using the distributive property, and later they say multiply using the FOIL method. I mean, I'm good using the FOIL method through and through. Both of them do really mean the same thing. I don't know if they're saying with the FOIL method to give some certain visual differences, but they all represent the same thing. The distributive property does state that each term in one quantity multiplies with every term in the other quantity. So what I can do here when it comes to distribution is I take the x and I will multiply it with this x over here. Because if you notice, it's x plus x times x minus 4. So I'm going to multiply the x with x and the x with negative 4 like this. And x times x there will be there, and then I'm going to add that with x times negative 4. And then I'm going to take the 6, and I'm also going to multiply it with the x and with the negative 4. So I'll add 6 times x plus 6 times negative 4. This is one of those examples where I'm writing this part right now, and maybe in the future I really won't be there. But x times x is x squared. X times negative 4 is negative 4x. 6 times x is 6x. That's literally what that means. And 6 times negative 4 is negative 24. Now we're not quite done. Two things need to happen. One, I need to combine like terms, and two, I need to make sure that I'm in standard form. I can almost guarantee you that all of these will be in standard form in the end, just because I think they're going to start them off in descending order of degree to begin with, so it'll be good. But you need to, but you need to combine like terms. There are oftentimes going to be a lot of terms, or not a lot of terms, but a set of terms that can combine with each other. So like the negative 4x plus 6x, those two can combine together. I add negative 4x with 6x and I get 2x. Positive 2x. So I get an x squared plus 2x minus 24 like that. And that would be the final result. That's after multiplying everything out through distribution. Yada yada. This just continues again. More a lot of drill and kill today, guys. A lot of drill and kill. 2x is going to multiply with x. I'm going to get 2x squared there. 2x is going to multiply with negative 3. Negative 3 times 2 is negative 6. And then x, there's the x. And then 5 times x, we'll get a positive 5x. And 5 times negative 3, we get negative 15. All right. Once again, the inner terms, these are linear terms here that will very often combine as long as you got some linear binomials here, 2x plus 5x minus 3. So I got these two linear terms in the middle that will once again combine. Negative 6x plus 5x becomes negative 1x. So I'll just write a minus x there and then minus 15. There's that end result. You know, and some of these, you guys get so fast at this at some point when you practice that a lot of it can become mental. Check this out as I say this out loud. Here's what's going to happen. X squared plus 1x minus 6x minus 6. X squared plus 1x minus 6x minus 6. That's after multiplying all those things. Now the x squared and the minus 6 on the outsides of those are not going to combine with anything. But the 1x and the negative 6x will combine. That becomes negative 5x. So ultimately this becomes x squared minus 5x minus 6. That's the end result of that. So you can see how fast some of these things can become. And I'm really comfortable doing these ones whenever it's just an x and x, because not only is that a variable that listen, you do this enough, you get comfortable with certain things. And what I'm very comfortable with is the idea of linear binomials here, because I know the two middle terms will combine. That's just something I've done forever. So I'm just used to just knowing, like, hey, first and last term like this, middle two terms to combine. So really all I'm thinking of is what's 1 minus 6. All I'm thinking of is what's 1 minus 6, and I'm going to throw an x in there. Kind of a nice little, I'm a creature of habit for that. All right, now this one has an x squared, so I'm just going to, I'm going to get a little more careful with it. I'll spell it out again. X squared times x and x squared times negative 4. Notice, by the way, I'm not multiplying x squared with 3. That doesn't make any sense. X squared is not multiplying with 3. It's adding with 3. It's multiplying, though, with those two over there. So I do have x squared times x here. And then I have adding x squared with negative 4. Remember that 4 is negative. And now let's take the 3 and do the same thing. Again, no different from before, only now with an x squared. I'm just going to be careful with the numbers. I want to make sure you know how to multiply the things with extra exponents, things like that. 3 times x and 3 times negative 4. All right. X squared times x is x cubed, because x is x to the first power. If you know, the exponents add when you multiply the variables together. So x squared times x is x cubed. X squared times negative 4 is negative 4x squared, of course. That's what that means. Negative 4x squared means negative 4 times x squared. 3 times x does mean 3x. And 3 times negative 4 is negative 12. Nothing combines this time. This is also in standard form, but nothing combined this time. I have degree 3, degree 2, degree 1, degree 0. Still 2 minutes. There were like 3 minutes left when I went. There must have been a lot of timeouts and commercials. Degree 3, 2, 1, and 0. Nothing combined there. So, just be okay with that. That can happen. Likely to happen again as well right here. X squared times x, that gets us x cubed. X squared times 6 literally is 6x squared. 11 times x is 11x. And 11 times 6 is 66. Nothing to combine. Hopefully these feel pretty easy peasy after some time, but again, these are just binomials times binomials, and we get to have 6 more even after these first 6. So again, I hope that the drill and kill is pretty fine. And this last one here on number 6, see if we can do it mentally without drawing all the arrows. Just know x squared is going to multiply with x and negative 5, and 8 is going to multiply with x and negative 5. Here we go. X cubed minus 5x squared plus 8x minus 40. A lot of these can go without work there when you're doing binomials with binomials, unless they're like terms to combine and you're not comfortable with just combining the inner linear terms when that kind of thing happens. All right, now let's say multiply using the FOIL method. Now, literally, there is no difference. Visually, they might give you a different way of writing something, as in FOIL is actually it's an acronym. It's a mnemonic device that stands for first, outside, inside, last. For two binomials multiplied together, a way of remembering how to do that you multiply x with x and 7, and you multiply 3 with x and 7, is by stating FOIL. FOIL first meaning that you multiply the first term in one quantity by the first term in the other quantity, x with x, and you get x squared. Outside meaning you multiply the two outermost terms, this x and this 7 together, those are the outside, x times 7 is 7x. 3 and x represent the inside terms here, right? These two terms inside, 3 and x, that gives you 3x. And then L is last. Not the last two like x and 7, that doesn't really make any sense because they're adding, but the 3 and the 7, the last two terms in your two quantities. You're always multiplying something in one quantity by something in the other quantity. 3 times 7 is 21. Your ultimate result, of course, is you are adding these results. If they were negative and you add a negative, it becomes subtraction. So you just make sure that you're aware of that. So there's that FOIL method. Just in a nutshell, nothing's changed, right? Literally nothing's changed. You can see the arrows that I made here. Even the order I did them was the exact same. And I still have to combine like terms. 7x plus 3x gives me 10x. So I got x squared plus 10x plus 21. It's in standard form. We're all squared away. But I'll keep stating FOIL right now. So FOIL again means first, outside, negative 8x, inside, 2x, last, negative 4, 2 times negative 2. Negative 8x plus 2x is negative 6x. Combined like terms, we get 4x squared minus 6x minus 4. Pretty fun, right? I mean, these are the things, it's the kind of math that, you you really, there's a bit of a reward in when you feel like you know what you're doing, and I hope you do. I hope some of this is making sense and you feel kind of accomplished with it as you're just multiplying through with me. Here we go. First, outside, inside, last. Let's go fast on this one. This is 6x squared. It's not just 6x, right? X times x still multiplies. Outside, 3x times 5, 15x. Now, this is going to add with the inside. 2 times 2x is 4x. 15x plus 4x, right? That's 19x. Can you go without that extra step? I don't know. 2 times 5 is last. That's 10. All right. Looking good. You guys are looking good so far. Awesome. All right. Number 10. FOIL method again, of course. Now, first is x squared times x, which is x cubed. Outside is x squared times negative 4 is negative 4x squared. Inside, negative 6 times x is negative 6x. Last, negative 6 times negative 4. I don't know, it's 24. I don't know if this is the first time we saw a negative on this part here, but I tell you what, if it was, I want to, no, it wasn't. I guess we saw it here as well. So just be careful. When you have a negative here, here's what tends to happen for people who do mess this up. What I tend to see, and remember, I always try and warn people of what they do here. You might have written the minus 4x squared beforehand or whatever, but some people write the minus because they see the 6 here. So they're like, okay, so minus, and then they do 6 times x, and then they do 6 times negative 4, like that. Oh, so be very careful, guys. That is still a negative 6. That is multiplying with negative 4. That becomes a plus right there. It definitely does. And anyway, nothing can combine. We are in standard form. All is swell there. It's really, really nice that I guess they always write them in that order. And listen, I'll be honest, guys. If they take one of these, if they wrote this as 9 plus x squared and x minus 3, I'm so comfortable and used to having leading degree terms in front. This would throw me off so badly, and I'd have to write it in standard form later in anyway. I would never leave it like this. I would go straight to I'd rewrite it like that for my own sake and sanity. That's just, it's a thing. We're more comfortable in some situations, and that's mine, even as a math teacher. Or especially as a math teacher, right? That's one I really want to just, talk about. All right, first, outside, inside, last. First, x squared times x cubed. Outside, x squared times negative 3 is negative 3x squared. Oh my gosh. Oh, that was x cubed. I'm sorry. Inside, 9 times x. That's 9x. Hey, come back. I'm trying to undo only just some. I pressed the undo button, but it has such a history of the last things that I wrote in. And then last, let's see, I didn't write anything or anything. 9 times negative 3 is negative 27. There we go. Negative 27. Nothing combines. That is an x cubed. Pardon me with that. That's an x cubed. Nothing combines there. All right. And last binomial times binomial, because after this we're going to be multiplying larger binomials with trinomials and things like that. Yeah, I'll just go ahead and put the arrows in one more time. First, outside, inside, last. FOIL, of course. Nothing really changed from the top. 4x squared times 2x is 8x cubed. You know what? Now that I think about it, I bet there is something that the top would have done instead. I show it in some of my other videos in the description if you want to see. I take a whole quantity and multiply by the thing. It's kind of weird. It's kind of, honestly, it's better to just stick with this. 4x squared times 1 is 4x squared. I think it's just one of those things that you use it to learn with, and then, that's why they introduce FOIL later. They build off it and they say, put on some training wheels to help yourself because you can. Anyway, that was a negative 4 times positive 1. Don't forget that that's a negative as well. All standard form. Nothing can combine. And we're good. All right. So that's the first 12 there. Let's move on to some more. Now we're going to multiply polynomials, not just binomial times binomial. Now you can see a binomial times a trinomial. Let me dispel this one part off the bat right now. You can't use FOIL. You can't use FOIL. FOIL stands for first, outside, inside, last. Imagine if I FOILed here. First, outside, inside, last. If you see a problem, we never multiplied by 2x here. FOIL are training wheels to help you have the understanding of polynomial distribution, but it's only for binomials. You can't do it. And you can try, I don't know, you can call it FOMIL if you do the middle and stuff as well. I don't really know. But the point is, in distribution of polynomials, each term in one quantity multiplies with every term in the other quantity. So x is going to multiply with x squared. X is going to multiply with 2x. X is going to multiply with 1. We are not done. Negative 3 is going to multiply with x squared. Oh my gosh. Negative 3 is going to multiply with 2x. Notice how I'm putting a plus. I'm automatically putting the plus in between, knowing that the signs that are going to come into play will change it when they need to. And then negative 3 is going to multiply with positive 1. Whew, that's a lot of writing right there. X times x squared is x cubed. X times 2x is 2x squared. X times 1 is 1x, also better written as x. Plus negative 3 times x squared is minus 3x squared. Plus negative 3 times 2x is negative 6x. Plus negative 3 times 1 is negative 3. Now we're not done. We do have to combine like terms, and also, of course, keep in mind standard form. This is one of those problems. I don't think I've ever done these mentally in the way that I went straight from here to final answer when all like terms are combined. Sure, I skipped this step here and there, but I'm going to write this step. Now I still have to combine like terms here. And there's nothing that combines with the x cubed, but 2x squared. I have a negative 3x squared right here. 2x squared minus 3x squared is negative 1x squared, also written as just negative x squared. Sorry, I'm just seeing the score. It's 29. I don't know. Washington. Well, they're in field goal range. It looks like they might win. X minus 6x is negative 5x, and then nothing combines with the negative 3 at the end right there. That's standard form, degree 3, 2, 1, 0. We're looking at a lot of cubic quadrinomials there, if you will. And this one looks like it's going to get a little bit bigger here. All right, let's see if we can do it without the arrows. But x is going to multiply with x cubed. I get x to the 4th. X is going to multiply with 6x squared. I get 6x cubed. Remember that x affects that thing. Everything's getting a degree higher because of the x. And x is multiplying with 18x, and I get 18x squared. Now 5 comes into the mix. 5 is going to multiply with x cubed, and I get 5x cubed. 5 is going to multiply with 6x squared, and I get 30x squared. 5 is going to multiply with 18x, and I get 90x. 6 terms to write out there. Some will likely combine. I have an x cubed with an x. Let me change the color. Did I change the color in the first one? No, that's right. I get an x cubed with an x cubed. Let's see what they were specifically. 6x cubed plus 5x cubed, that's 11x cubed. So x to the 4th plus 11x cubed. 18x squared with 30x squared gets you 48x squared. And then there's a 90x at the end. Once again, trying to get that standard form. X to the 4th, x to the 3rd, x to the 2nd, x to the 1st. And we are good to go. Number 15. Listen, really no difference, guys. I'm doing this for the nice drill and kill action, but I'm always trying to find different ways to spice it up. I can't really think of one right now. I'll give you something I'm going to do with 16 and 7. Oh my gosh, I'm going to do all those? I don't know. We'll see. With some of those, you'll see a problem that I incur in number 16 and how I can improve upon it, perhaps, because just so many terms here. But x, here we go. X times x to the 4th is x to the 5th. X times x squared is x cubed. X times 1 is x. I'm sorry if I'm going fast with this. It is just part of the process. When you multiply these so often, it's hard to go more slowly. 4x to the 4th, 4x squared, and 4 plus 4. There's, nothing might combine here. You know, this one was kind of fun because 4 didn't, just a 4. And then the x has just brought up these degrees here. Yeah, nothing's going to combine, but we do have to rewrite this, right? Let's get in standard form. We have degree 5, 4, 3, 2, 1, 0. So I'm going to get x to the 5th plus 4x to the 4th. Looks like all the even degrees will have a 4 coefficient, or the constant. Plus x cubed plus 4x squared plus x plus 4. Ooh, that's a fun problem right there. That's pretty good. Enjoyed that one. Wait, the time is down. Huh. All right, number 16. Now, what you can imagine with this one, just as it gets a little, rambunctious here, is there's just going to be a lot of terms. If you imagine this term's multiplying with these 4, and this term's multiplying with these 4. So when you write it out, guys, it is going to be 8 terms. It's going to be a little bit, but you know what? Let's go through it. Let's see if you're more than willing to see this long line of events as we write these through. So here we go. X times x to the 5th is x to the 6th. So basically, this x is going to multiply with these, and it's just going to raise this 5 to a 6, this 3 to a 4, this 2 to a 3, and this 1 to a 2. So now I'm going to get plus 4x to the 4th plus 6x cubed plus 2x squared. And then negative 6. Now remember, all these are positive multiplied by this negative. Every sign is going to change right here. Every sign is going to change right here. So I'm going to get minus 6x to the 5th minus 24. That's negative 6 times 4, 24x cubed, minus, looks like 36x squared. Hey, Washington won. Field goal, it looks like. There it is. At least they got one thing right, that they were going to win. Minus 12x. All right. Now we got to combine like terms, and this is the part where you got to start hunting here. I have an x to the 6th only. Do we have an x to the 5ths? Look for them. Here's one, and it looks like that's it. So negative 6x to the 5th. You can do one of those things like I do where you start crossing things out when you find them. So like x to the 4th. Here's a 4x to the 4th, and I think that's the only x to the 4th. Does that make sense? Yeah, there's only one. So plus 4x to the 4th. Nothing's combined yet, which means there's a lot more to combine down the line. 6x cubed minus 24x cubed. That's going to give me negative 18x cubed. Now let's look for the x squareds. 2x squared minus 36x squared is negative 34x squared. And then minus 12x. And I think you're going to start appreciating standard form a lot if you haven't yet gotten like, why do we do it? At some point, you just appreciate it. You look at it, and this polynomial is just so clean looking when you do that. regardless of the coefficients, just that 6, 5, 4, 3, 2, 1. Just going down the list is nice. All right, two more. Trinomial times trinomial here. Now, these get a little expansive. Let me show you something that you might not want to do what I did in these last several problems, which is this arrow business and writing in one line, for two reasons. Number one, you're going to get 9 total terms written out when you expand. And this is 8 terms. Imagine even a 9th after that. It gets a little long. Number two, it's really hard to do the arrows because you got to do each term in the trinomial with every term in this one. That means it has to do these, and what am I going to do with the 3 when I draw arrows? I guess this. That's a lot, right? It's more than confusing. And I mean, listen, you don't have to do any of those. You don't have to. It's just a nice visual to help you out. But let me give you an alternative of what you can do, and maybe this can organize your work better. There are some benefits to this that can be used, and here's one to consider. Let me get it more of a box here. I'll get all the rest of the stuff inside there. So in this box here, I'm going to make a 3x3 grid, and I'm doing a 3x3 because this is 3 terms by 3 terms. And imagine that these are rectangles, squares, whatever you want to call them. Imagine that these are something where each term represents a single length, a single portion of this bigger square, and it's like we're finding its area. Let's say I take x squared, x and 3, and write them all, right here. I don't need the pluses necessarily, but I will need minuses if we have minuses. So x cubed, negative x squared, and 4 will go down this list. Because when you multiply things, it is kind of like a base times height kind of thing, So it's like I'm doing base times height and I'm getting area, but I have these different terms represented to get little individual rectangles or squares to multiply. So every little box, I'm going to multiply a row times a column, and I'm going to get a result. So x cubed times x squared, remember, you add the exponents, 3 plus 2, and I get 5, x to the 5th, right there. Now I'm going to multiply x cubed. Remember, all these represent x cubed right here. I'm going to multiply x cubed with x, right? Boom, boom, x cubed with x there, and I'm going to get x to the 4th, and then x cubed times 3, and I get 3x cubed. Now I have this negative x squared, and remember, I think that does help seeing the negative there and just remembering all these will be negatives here. Negative x squared times positive x squared, that's not 0, we're multiplying, that's negative x to the 4th, right? X squared times x squared. Negative x squared times x is negative x cubed, and negative x squared times 3 is negative 3x squared. And then 4x squared, 4 times x squared there, 4x and 3. 4 times 3 is 12. And, this may be more trouble than it's worth. I'm not really sure, but sometimes you get little, some organization things that do help you writing this. The end goal, though, is that the area of this whole thing is you got to add all these things up. Adding negatives means subtraction, but, maybe you got to rewrite them now or find things that can combine all within here. So there's only a single x to the 5th. Let me cross out things when I've taken care of them. So I have an x to the 5th there. Let's find any x to the 4th. I have an x to the 4th here. I have an x. Oh, look at these. X to the 4th minus x to the 4th. Now that is 0. x to the fourth minus x to the fourth is 0x to the fourth or 0. They're just gone. I don't even need to write this. It's just bye-bye. It's not there anymore. X cubed. 3x cubed minus 1x cubed. That'll be a positive 2x cubed. And it looks like those are the only ones. So plus 2x cubed. Negative 3x squared plus 4x squared is 1x squared. I should have said 4x squared minus 3x squared. That's 1x squared, so plus x squared. And then a plus 4x and a plus 12, which do not combine. I'm just going to cross them out so I can write them out. Plus 4x plus 12. Again, I don't know if that's more trouble than it's worth or less. I think it helps for organization. It gives you another little idea of what you can do. I don't know if listen, I'm not going to do it. If you gave me this problem and I was testing, I'm just going to do my own thing. I'm not going to draw these. I mean, if you want me to go speed round on one of these, check this out. Here's me going on this one. I'll say them out loud, but x cubed times x to the fourth is x to the seventh. X cubed times negative x cubed is negative x to the sixth. X cubed times x squared is x to the fifth. X squared times x to the fourth is x to the sixth. X squared times negative x cubed is negative x to the fifth. X squared times x squared is x to the fourth. 2x times 2x times x to the fourth is 2x to the fifth. 2x times negative x cubed is negative 2x to the fourth. 2x times x squared is 2x cubed. So there's my expansion of those 9 terms there. And, I didn't have to, you're probably still drawing the box and writing those things out while I've taken care of that portion. Now, I'm not done because I still have to combine like terms here. I know nothing's going to combine with that x to the seventh, but x to the sixth, I got negative x to the sixth, positive x to the sixth, bye-bye. I got x to the fifth minus x to the fifth, bye-bye. X to the fourth minus 2x to the fourth is negative x to the fourth. Let me cross that out while I'm at it. And 2x to the fifth. Hold on. I got a 2x to the fifth first, and then minus x to the fourth. Then minus x to the fourth, and then the plus 2x cubed. All right, there it is right there. So, it's kind of your call. I didn't draw all those little things right here, though, because, again, the hecticness of this, I don't know, kind of three-dimensional tactic, because I got to do this more than once on one side of it. It gets a little confusing there. But that's that result. All right, just a couple more problems here. Let me see which ones I want to do. Just 19 and 20, 2 more problems, and all they're doing is they're giving you another visual representation, making sure you know how area works. They're talking about a rectangular garden here. Cameron is creating a garden. I guess that's Cameron. Cameron's creating a rectangular garden. He designs it with a length of x plus 6 feet and a width of x plus 2 feet. So say this is x plus 6 feet, and this is x plus 2 feet. And I drew out a rectangle there, and the area of a rectangle is length times width. So they give us length, they give us width, and then they say when x equals 5, what is the area of the garden? Now you might want to just plug in 5 right here and multiply, but be careful, they want you to write a polynomial equation for each situation. So if the length is x plus 6 and the width is x plus 2 and the area is length times width, they want you to write out an equation that says area equals x plus 6 times x plus 2. There's the length times width. I'm sure they even want you to expand this polynomial through FOIL, right? X squared plus 2x plus 6x plus 12. X squared plus 8x plus 12. That was my 6x plus 2x right there, combined like terms. So here's a representation of the area as a quadratic trinomial. And then they ask, okay, so what is the area of the garden when x equals 5? Now I can use this simplified one. Yeah, I'm sure this would have been faster to do, just 5 plus 6 times 5 plus 2. But, let's appease the section that we're in. Let's substitute 5 into here because they're talking about when x equals 5. Let's do 5 squared plus 8 times 5 plus 12. 5 squared is 25, 8 times 5 is 40, then plus that 12 right there, and we're going to get 65 plus 12 is 77. Now, in terms of area, this is feet, the length is feet, so area is square feet, like that right there. 77 square foot garden. If you want to confirm it, again, this would have been faster. 5 plus 6 is 11. 5 plus 2 is 7. 11 times 7 is 77. But just the result, you get the same answer there. Just know that knowledge is enough. One more, I think the same kind of problem. Let's see if this is what I want to Let's see. Do I want to do this one? You know what? I'm good on this one. I just wanted to get some rectangle stuff, and there's an example of a process there. So that ought to do it for this one, guys. This is Mr. Robinson. Thank you so much for watching. I sure hope that helped you a little bit, especially when I started speed rounding it, and now I'm at 30 minutes. Take care.